In this section, we'll cover the correct measurement techniques and operational tips for Bus Expert 2. We'll go over some effective testing recommendations, including topics like anti-static precautions, grounding, frequency settings, and more. We'll also explain how to enhance testing results through special function calibration and data processing. Mastering these basic measurement techniques and operational tips will help you perform tests more efficiently and accurately, ensuring the reliability of your test results. When using Bus Expert 2 for testing, it's important not only to set up the instrument and measurement conditions correctly but also to follow some useful tips that can improve measurement accuracy and protect both your equipment and the device under test from damage. In this section, we'll go over several important usage recommendations to help you perform more efficient and stable measurements. Static electricity is one of the main sources of interference that can affect measurement results, and it can also damage your test equipment and the device under test. During testing, static electricity can accumulate silently and even discharge unexpectedly. This discharge can not only affect measurement accuracy but also cause permanent damage to your equipment or the device you're testing. Wearing an anti-static wrist strap is a key step in preventing static buildup and safely discharging it. The wrist strap connects to a ground wire, directing any static electricity safely to the ground, ensuring that it doesn't get transferred to your equipment. By wearing the wrist strap while handling the instrument and connecting the device under test, you protect both the Bus Expert 2 and the device from static discharge. This not only extends the life of your equipment but also ensures the accuracy of your measurements. Solder enamel wire to a 2.54 mm pin header. Signal connection stability is crucial during measurements. If the connection is unstable, it could lead to signal loss or distortion, affecting the precision of your test results. Therefore, selecting the right connection method is critical. The best method is to leave test points and test pin headers on the circuit board. Soldering enamel wire to a 2.54 mm pin header provides a more stable signal transmission. The 2.54 mm pin header is a standardized connector that ensures a reliable connection with the B2 test probe. Be mindful of stress when using coaxial cables as enamel wire is relatively soft. When connecting enamel wire, avoid any crossed wires. Choosing a stable and precise connection method is essential to ensure measurement accuracy. Proper grounding is crucial for ensuring signal accuracy and measurement stability. The length of the ground wire and its stability of contact directly impact the quality of the signal. When the ground wire is too long, it increases ground impedance, which can introduce extra noise and affect measurement accuracy. Therefore, it's important to place the ground point as close as possible to the measurement point to minimize unnecessary long-distance transmission and noise introduction. If the grounding point is too far from the measurement point, it can cause unnecessary interference and noise, making it harder to process the signal and leading to less accurate measurements. Grounding should be close to the measurement point to minimize the noise generated by long-distance transmission. Following these usage tips will significantly improve the stability and accuracy of your measurements, while also protecting your equipment from static electricity, unstable signal connections, and improper grounding. Here are some recommendations for setting the sampling frequency. When you're performing measurements, the sampling frequency should be set to 6 to 10 times the highest frequency of the signal you're testing. This ensures you capture the full waveform of the signal and avoid missing any of its frequency components, which helps improve measurement accuracy. For example, if the highest frequency of the signal under test is 50 MHz, the sampling frequency should be set between 300 MHz and 500 MHz. This will allow you to capture the high frequency changes in the signal and avoid errors caused by insufficient sampling rates. If you're testing whether the device under test switches operating frequencies frequently, it's recommended to set the sampling rate to 2 GHz. A higher sampling rate like this ensures you can accurately capture those fast signal transitions and observe each switching event in the timing diagram. A high sampling rate helps you avoid missing critical transient changes, which is key for high precision measurements. When measuring data packets or cyclic redundancy check, it's recommended to use a 2 GHz sampling rate. This will help you precisely capture the structure and content of each packet. It's especially useful when analyzing protocols, as it allows you to detect any potential errors or anomalies in the data. In high-speed data transmissions, packet changes and CRC checks can be very subtle, and using a higher sampling rate will help you identify potential errors or issues, thus improving test reliability. For high-speed storage protocols like eMMC, it's also recommended to use a 2 GHz sampling rate. eMMC operates at high frequencies, so a higher sampling rate is necessary to accurately capture every detail of the data transfer. By following these sampling frequency recommendations, you can ensure that your measurements are accurate and reliable, especially when dealing with high-speed or complex signals. Understanding when to use logic analyzer mode versus protocol analyzer mode is very important. Each mode has its specific purpose and is suited for different measurement scenarios. Let's go over when to use each mode in detail. When to use LA mode. LA mode is mainly used for signal timing analysis. Here are some common scenarios where LA mode is effective. Measuring general signal waveforms, LA mode is great for basic waveform capture. Whether you're observing signal high/low level changes or capturing periodic waveform changes, LA mode clearly displays the waveforms and helps you verify if the signal is behaving as expected. For example, when inspecting the waveform of a digital signal, LA mode accurately captures every detail of the signal, helping you analyze characteristics like rising edges, falling edges, and high/low level transitions. Calibrating probes. When setting up your measurement system, ensuring that probes accurately capture the signal is crucial. LA mode can help you check if the probes are reflecting the signal changes correctly, allowing you to make necessary adjustments to ensure measurement accuracy. By using LA mode, you can review the signal output from each probe, fine-tune them, and make sure they are capturing the signal accurately. Ensuring the probes are calibrated in LA mode helps prevent misinterpretation in PA mode. Checking clock switching speeds on the DUT, device under test. When measuring certain digital devices, LA mode is effective for checking if the clock switching speeds of the DUT are normal. If there are any clock abnormalities or switching errors, LA mode can clearly display and pinpoint the problem, helping engineers troubleshoot quickly. Verifying data packet structure and CRC, LA mode is used to check if data packet structures are correct and to perform CRC checks when analyzing data communication protocols. It ensures the integrity and accuracy of data transmission. LA mode captures the bits of every CMD/data packet and checks the CRC to ensure data is transmitted correctly. Verifying eMMC 5.1 DS and data timing. For storage systems like the eMMC 5.1 protocol, LA mode is ideal for checking the timing of data and command signals. LA mode helps capture the synchronization of DS, data strobe, signals with data signals, ensuring correct timing and synchronization. When measuring eMMC 5.1 devices, LA mode allows you to check the relative timing between data and clock signals, confirming whether data is correctly synchronized and transmitted. When to use PA mode. PA mode is mainly used for bus protocol analysis. Here are some situations where PA mode is best suited. Recording the entire boot process. PA mode helps capture all data exchanges during the boot process, allowing you to check if data transmissions are functioning normally during startup. This is very useful for troubleshooting errors in the boot process. During boot up, PA mode can capture and decode each packet, helping you analyze whether the device initializes as expected and check for any abnormal packets or errors. Verifying large data transfer accuracy. When performing large data transfers or storage operations, PA mode captures every packet's transmission process, helping you check for packet loss, errors, or delays during data transmission. For instance, when measuring data copy processes on eMMC or SD cards, PA mode effectively displays each packet, allowing you to check if the data flow is smooth and as expected. By choosing the right mode for your measurement, you can pinpoint issues more accurately, improve measurement precision, and enhance the overall efficiency of the testing process. When using Bus Expert 2 for measurements, it's crucial to perform trigger level calibration and adjustments to ensure accuracy and consistency in your results. Not only does this improve measurement precision, but it also ensures that the data is not skewed by any irregularities in the trigger signal. Now, let's go over how to perform trigger level calibration and I/O delay calibration, and discuss how they work in different modes. Automatic calibration is a really convenient feature. When you turn this on, the system will calibrate both the trigger level and I/O delay at the same time, making sure all parameters are in the best state for measurement. During the calibration process, the system will automatically adjust the trigger level and I/O delay parameters, which helps to minimize measurement errors. Once the calibration is complete, the measured data is automatically saved to your computer, so you can keep the same calibration results for future measurements. Tip: after finishing the automatic calibration, it's best not to move the probes to a different position, because any changes might affect the previous calibration and cause measurement errors. For trigger level calibration, we need to use a special calibration jig. This ensures that the trigger level for each channel is accurate. I/O delay calibration. I/O delay calibration is mainly used to synchronize delays between different channels to prevent any signal delay mismatches from affecting the measurement results. In LA mode, there are two methods for I/O delay calibration: hardware calibration and software correction. We highly recommend using hardware calibration in both LA and PA modes because it provides more precise synchronization and helps minimize errors caused by hardware delays. Hardware calibration adjusts the hardware settings of the measurement system to minimize delays between all channels. This is especially important for capturing high-frequency or fast signals, because even small delays can have a significant impact on the accuracy of the signal. On the other hand, software correction uses software to compensate for delays. It fine-tunes the delay for each channel, but compared to hardware calibration, software correction is less precise. So, in both LA and PA modes, we still recommend using hardware calibration for the most accurate results. It's also worth noting that for some devices, manually adding a delay to the data strobe signal can improve the measurement experience. This is because, in cases where the signal switching is fast or the signal quality is poor, adding a slight delay can help stabilize the signal and improve measurement accuracy. The main goal of performing trigger level and I/O delay calibration is to ensure the accuracy and consistency of the measurement process. This is the foundation for high-quality measurements, especially when performing detailed waveform measurements or protocol analysis. In Protocol Analyzer mode, recording protocol decodes is a powerful and essential feature. It allows us to focus on decoding specific bus protocols and handle large amounts of packet data for in-depth protocol analysis. Let's go over how this mode works and the key features it offers. Recording protocol decodes focuses specifically on decoding the bus protocol, allowing you to quickly capture and interpret commands, data, and control signals on the bus. This process only records the selected protocol data, ignoring unrelated signals or noise. This design significantly improves measurement efficiency and the accuracy of the analysis. Large packet recording. Since only the decoded bus protocol is recorded, you can capture large volumes of data packets without worrying about storage limitations. This is especially useful for long-term protocol analysis, complex data transfer processes, or when conducting in-depth investigations of large numbers of packets. 3-table linked operation. After recording the decodes, the system displays 3 main analysis tables that interact with each other to display various types of information. These tables include CMD sort table. This table shows the frequency of each command, giving you insight into how often each command appears and how it's being executed. CMD list table. This table lists the execution order of each command, clearly showing the sequence and timing of commands within the protocol. Packet list table. This table shows all the decoded packets and provides full packet data. You can examine each packet's details and perform further analysis. These 3 tables are interactive, meaning that when you select a command or packet in one table, the data in the other tables automatically updates to show the related details for the selected command or packet. After recording large amounts of data, finding a specific data packet can become quite complex and time-consuming. The data search feature offers a convenient solution, allowing you to quickly locate the data packets that you are interested in. These features not only assist with protocol analysis but also greatly enhance the accuracy and efficiency of the analysis, making your testing process more effective and intuitive. When decoding protocol data, we're not just capturing the transmitted packets, we're also doing a detailed analysis of the internal structure of each packet. For example, with common protocols like eMMC or SD, we show the various fields within each packet, such as commands, parameters, and response data. These fields make it easy for you to see how each step of the protocol is being executed. With this detailed packet structure analysis, you can quickly identify protocol-level issues. For example, you can spot errors like command mistakes, CRC checksum errors, or even packet sequence issues. This kind of decoding analysis makes troubleshooting much simpler and more efficient. The software presents the data in each protocol packet in a structured and clear way, so you can easily understand every detail. Engineers or technicians don't need to read through complex protocol specifications anymore to interpret the data. This is a huge time saver. As a result, this functionality allows for more efficient protocol analysis and issue diagnosis, whether you're testing system performance or troubleshooting protocol-level problems. It truly is an invaluable tool. Now, let's talk about the lossless long-duration recording and compression feature, which is designed specifically for scenarios that require capturing signals over long periods while ensuring data accuracy. Lossless long-duration recording means that you can capture signals 100% over extended periods without any data loss. This is crucial for tests that require long durations, especially when analyzing the behavior of devices or systems running for extended periods. In traditional setups, during long-duration recordings, some signal data may be lost due to limitations in storage performance or the USB device's handling capacity. This can negatively impact the accuracy of the test results. However, the lossless long-duration recording feature ensures that all data paths are validated before recording, guaranteeing that every signal is captured completely without any omissions. This helps maintain data integrity throughout the testing process. Lossless recording isn't limited to just certain types of tests, it's applicable to any testing environment that requires extended recording. Whether it's for communication protocol testing, system boot monitoring, or detecting complex data transmissions, lossless long-duration recording ensures stable and highly accurate test results. In this section, we're going to dive into the triggering and signal processing features of the BusExpert 2, B2. The B2 offers two main triggering modes, general triggering and protocol triggering. Each of these modes has different applications and can be adjusted based on your specific needs. Understanding the trigger settings on the BusExpert 2, B2, will help you capture signals under various conditions and make your measurements more flexible and precise. Setting multiple trigger conditions. Edge triggering is the most common trigger type, typically used to capture the rising or falling edge of a signal. When the signal crosses a preset threshold, the device will trigger and start capturing. The multi-stage trigger setup allows you to define multiple levels of trigger conditions, making signal capture even more flexible and accurate. In multi-stage trigger mode, you can define several trigger conditions. Each stage's trigger can be activated based on the result of the previous stage, enabling you to capture more detailed signal information. For example, you can set the first stage to trigger on a rising edge of a clock signal that meets a specific logic condition, then set the second stage to trigger on another clock signal's rising edge with a different logic condition. This way, you can capture the changes between two key states. In practice, selecting the appropriate trigger method based on your specific needs will greatly improve the efficiency and accuracy of your testing. The BusExpert 2's protocol trigger feature is designed for users who need high-precision, protocol-level measurements. It helps you pinpoint protocol issues during testing and boosts your debugging efficiency. One key feature of the B2 is protocol decode triggering. This allows you to trigger based on protocol data packets. This kind of triggering lets you measure specific bus protocols, ensuring that you capture the right data. The eMMC and SD protocols are the main protocols supported by the B2. Another powerful feature of the B2 is specific packet triggering. This lets you trigger based on the content of the protocol's internal packets. You can set trigger conditions to detect specific commands, addresses, or data packets. For example, in the SD or eMMC protocols, you can set a command trigger so that when a specific command appears, the device starts capturing signals. In addition to commands, you can also set triggers based on the parameters associated with the command. When specific parameters appear in the protocol, the device will trigger. This is especially useful when you need to perform precise data path analysis. Specific packet triggering enables you to accurately capture the appearance of a key packet within the protocol. This is very effective when diagnosing specific operations or troubleshooting errors. Such a setup lets you focus on analyzing specific protocol interactions without having to capture all signals, which reduces data volume and improves testing efficiency. Now, let's take a look at some of the other convenient features of the Bus Expert 2, designed to enhance user convenience and significantly improve operational flexibility and efficiency. Whether it's language selection, data processing options, or statistics and export features, these designs help users quickly set up, perform accurate data analysis, and efficiently export and share results in various testing scenarios. These convenient features not only improve the efficiency of the testing process, but also provide users with more customization options, allowing them to flexibly adapt to different testing needs and ensure that you achieve the best possible results in your work. The B2 supports languages including traditional Chinese and English, allowing users to switch the language of the interface according to their needs. This design provides a more intuitive and user-friendly experience, especially for users from different language backgrounds, as switching languages helps reduce misunderstandings or operational errors. The Bus Expert 2's data statistics and analysis feature helps users better understand measurement data, improving both analysis efficiency and accuracy. The signal data statistics function provided by B2 allows you to perform cycle count statistics within a specific range. For example, if you're analyzing a data packet with a length of 512 bytes and a data width of 4 bits, you can quickly use the statistical analysis feature to confirm whether the clock cycles within the analysis range add up to 1024 cycles. In Bus Expert 2, the data export feature is a crucial capability. It allows measurement results to be not only displayed on the screen but also conveniently exported for further analysis and reporting. Whether in LA mode or PA mode, B2 provides various data export options to effectively support different workflows and needs. Logic Analyzer mode allows exporting waveforms or packets, while Protocol Analyzer mode exports packets. In LA mode, users can choose to export the measured signal waveform or the decoded packets. This allows for subsequent processing or analysis of the signal's time waveform or packet statistics and analysis. In PA mode, users will export protocol-level packet data. This is because in PA mode, B2 primarily decodes and analyzes bus protocols, not just the waveforms. Therefore, the export results will focus on the protocol-level data rather than the raw time waveforms. This distinction ensures that, whether conducting general logic analysis or protocol decoding analysis, B2 can flexibly provide the necessary data export options. Supports common formats like CSV, text, and others. B2 supports several common export formats, such as CSV format, one of the most common data export formats, which saves the data as a comma-separated text file, making it easy to process in Excel or other data analysis tools. Text format, a plain text format, suitable for saving data in a simple text file or processing in other custom tools. These supported formats allow users to choose the most suitable data export method for their needs and then perform further analysis and processing in different software tools. Convenient for further processing, compatible with various data analysis tools. The data export formats from B2 are ideal for subsequent processing. Whether it's for data statistics, curve fitting, or protocol-level decoding analysis, the data can be easily imported into a range of data analysis tools. Common data analysis tools include Excel. Users can import the exported CSV file into Excel and use built-in analysis features for basic data processing and visualization. MATLAB or Python. For more advanced data analysis needs, B2's data export format can be easily imported into these tools for more complex data analysis and computation, leading to deeper insights. These features allow users not only to perform preliminary analysis on B2 but also to export data and carry out advanced analysis using professional tools. 4.0 Mini. The software toolbar features in BusExpert 2 offer an intuitive, easy-to-use interface that allows users to quickly access common tools during measurement and analysis. One-click access to essential functions, quickly reach trigger, analysis, and other tools. B2's toolbar design lets users access frequently used functions, like trigger settings and data analysis, with just one click. This setup simplifies the workflow, avoids complex menu navigation, and enhances users' response speed during testing. It helps users make faster, more flexible adjustments, boosting overall work efficiency. Customizable toolbar. Configure buttons for your most used features. B2's customizable toolbar allows users to set up buttons based on personal needs and work habits. You can freely add or remove buttons on the toolbar according to your testing requirements. For example, if there's a feature you use frequently, you can place it on the toolbar for quick access. Additionally, users can adjust button positions, keeping essential tools in the most visible spots for better convenience. This customization provides a personalized experience, enabling each user to optimize the toolbar based on their own needs, significantly reducing operational time. Enhanced efficiency and time saving in testing. Overall, B2's software toolbar greatly improves operational efficiency, saving time during the testing process. With one-click access, flexible customization options, and a clear visual layout, users can quickly adjust settings and perform essential actions, avoiding lengthy steps and accelerating the testing workflow.